This is the third and the last video in Chapter 1, Matter in Our Surroundings. In this video, we'll discuss about evaporation. But before we go to the main topic, these two definitions, melting point and boiling point, we missed in our last video. Melting point is defined as the temperature at which solid starts converting into liquid. So the temperature at which ice will start converting into water will be known as its melting point, and this temperature is 0 degrees Celsius or 273.16 Kelvin. Boiling point is defined as the temperature at which liquid starts converting into gases on heating. For water, this temperature is 100 degree Celsius or 373.16 Kelvin. Evaporation is defined as the process by which liquid starts converting into gases or vapors from the surface below the boiling point. So there are a few differences between boiling and evaporation. On the left hand side we'll write boiling, and on the right hand side we'll write evaporation. So boiling, the first difference is that boiling occurs throughout the liquid, whereas evaporation occurs on the surface. The second difference is boiling requires heating up to the boiling point, whereas evaporation occurs below the boiling point. So this occurs below the boiling point. Third difference is that evaporation is always happening. So evaporation occurs always. So even if we are not boiling or heating the substance, evaporation is always happening. Whereas boiling happens only when we are heating a liquid and it reaches a certain temperature, which is its boiling point. Next topic is factors affecting evaporation. So there are a few factors that affects evaporation. First one is temperature. As we increase the temperature, rate of evaporation also increases. And this increase is because of increase in kinetic energy. So increase in temperature is directly associated with increase in heat, and increase in heat provides sufficient amount of kinetic energy to the particles of liquid present on the surface to escape and convert into vapors. Next factor that affects evaporation is wind speed. As we increase wind speed, the rate of evaporation also increases. So wind carries the vapors present in the atmosphere. So this wind will carry away these water vapors, making space for new water vapors to go into the atmosphere. And that is how wind speed increases the rate of evaporation. The next factor that affects evaporation is surface area. So with the rate of evaporation increase with increase in surface area. So as the surface area will increase, the rate of evaporation will also increase. For example, this is a small beaker with a smaller surface area, and this is a large bowl with a larger surface area. Here only lesser number of particles will be exposed on the surface to be evaporated. However, a larger surface area will provide access to larger number of particles on the surface of a liquid to be evaporated, and that is why the rate of evaporation increases with increase in surface area. Next is humidity. Humidity is defined as the amount of water vapors present in air. So if already the air would have enough amount of water vapors, it will not have space for more vapors to come into the air. So rate of evaporation decreases with increase in humidity. humidity. So if the humidity is high, the rate of evaporation is low. Another property of evaporation is that it causes cooling. While the particles from the surface are converted into vapors, these particles on the surface tend to gain energy from the surrounding particles to be converted into vapors. And as these particles move in air, the energy of the particles left behind becomes less. And due to that lesser energy, these particles or the remaining liquids becomes cool. Few examples where this property of evaporation comes into play are these. The first one is sweat. When we sweat in summer, we see some water droplets on our body. These water droplets are evaporated as the wind blows, and these convert into vapors. In doing so, the water absorbs energy from our body, reducing the amount of energy on our skin, and that is why we feel cooler. Next example is of a pot. The water in pot, you must have observed, that remains cooler. This is because the pot is made up of soil or clay, and soil has tiny pores in it. The water evaporates from these tiny pores, collecting energy from the remaining water, and the remaining water becomes cooler. Another example is of the desert cooler. As the water flows, some of it is evaporated, and while doing so, it absorbs energy from the remaining water, and the remaining water becomes cooler. Also, some of the energy is absorbed from the air present in the water cooler, and also the air in the cooler becomes cool. Next example is of acetone or hand sanitizers. So when you put hand sanitizers or acetone on your palm, it becomes cool because the boiling point of acetone or hand sanitizer is very less, and they convert into vapors at very low temperatures, and while doing so they absorb energy from your palm, which makes your palm feel cooler. So some important questions that are asked from this part. The first one is, why do we wear cotton clothes in summer? So cotton clothes are very porous and they are good absorbers of sweat. So they absorb sweat and brings it to the surface, and from the surface the sweat is converted to vapors while absorbing heat energy from our clothes, which makes us feel cooler. Another question that is asked here is, why do we observe water droplets on the surface of a tumbler filled with cold water? What actually happens is there are already water vapors present in the atmosphere, and when these water vapors comes in contact with cool walls of the tumbler, they are converted into water, and this process is known as condensation, as we have discussed in our previous videos. Thank you for watching. That was all in the first chapter, Matter in Our Surroundings.